This is a continuation of Chapter 6 quiz videos. On problem number 10, they talk about aircraft ejection seats for men, and they give you a weight range of 144.5 to 214. Women is normally distributed with a mean of 170 and a standard deviation. What percent of women fall within these limits? This problem is exactly the same as the previous problems that we've done, in that we are looking at the area between two values. So looking that up, we can do that. The question then wants to know, are many women excluded from this? Well, once you get the percentage, you know whether the percentage is sufficient, and what you'll get is a 54.53, and in this particular example, and because it's small, a lot of people, only 54% of women will fit into this. So the complement of that is 45 point something percent will be excluded. That's a lot, quite a few people that are excluded. So the percent of women who are excluded is the complement, and it shows about half the women are going to be excluded. So when you get to these kinds of parts of the problem, think about what's happening and use some practical knowledge and some common sense to answer those questions, okay? Number 11 is the kind of distribution this is. The normal distribution, the sampling distribution of a statistic. So when you have what's going on here is we're talking about when the sample size is bigger than 1. All the problems before this, the sample size was 1. If a woman, what's the percent of women, what is one woman to do this? Those are the percentages. We're talking about those things. We're not talking about a specific sample. Now, when you have a sample size of less than 30, the population's got to be normally distributed. If it isn't, then you really can't use these methods, okay? So 13, 14, and 15 are very important, and I want to call your attention to it because of what happens. There's two parts to these problems. The first part is the probability when the sample is of size 1, in which case it's going to be exactly like all the problems that we've done in the second video. However, when you are dealing with a probability of a sample greater than 1, you're not talking about an X value here, you're talking about an X bar value, and that's what the difference is, okay? And so what happens here is you are talking about the mean of the sample rather than a single value. And so, for example, number 13, if one adult female is randomly selected, 70 beats per minute, A2, they want to know what happens. So watch what happens here on the calculator. So the problem is very much like what we've already done, okay? But watch what happens here. Let me get the standard deviation. I want the probability, so I'm going to go to second, I'm going to turn this on, second var, and I'm going to choose normal CDF, okay? One adult female, and so probability is between 70 and 82, so I'm going to put 70, comma, 82, and then a comma, and then the mean, which is 76, comma, and then the standard deviation, which is 12.5. Oops, let's back up here and put a decimal point in there. Okay, and close the parentheses and press enter. Okay, so now that's the probability of one adult female falling between these. But now look at how part B is written. If 25 adult females are randomly selected, find the probability that they have a pulse rate with a mean. They meaning all 25 adults. This is not the same problem as A. So I'm going to go back to my formula. I'm going to choose normal CDF. I'm going to put in my 70, just like I did before, my 82, just like I did before, my mean of 76, just like I did before, and here's where the difference comes. Because I have to account for 25 adults rather than one adult, instead of the standard deviation I'm going to use is 12.5, I'm going to use 12.5 divided by the square root, that's second square root, of n, which is 25. Now you know square root of 25 is 5, so you could put a 5 in there if you wanted to. But you don't have to do the calculations if it's something that isn't a perfect square. And I'm going to close the parentheses on the normal calculator and then do it. Notice the difference. The probability of one woman falling between 70 and 82 beats per minute is 37%. The probability of 25, the average of 25 falling between 70 and 82 is 98%. There you got your answers. Okay? Now the question then says, why can the normal distribution in part be even though the sample size does not exceed 30? It can because it tells you that females in general have a pulse rate that's normally distributed. Okay? So those are the kinds of questions that are on 14 and 15, and those are the ones that you want to try and solve. I hope you found these 3 videos helpful. Look them over again. Do the quiz another time to make sure that you understand these concepts. They are extremely important going forward in the last half of this course.